this lesson, we will discuss the uses of whole numbers and concepts that will help foster the ideas of number and place value. Recall that a group of elements is called a set. Here we have a set of animals. How might we use numbers to discuss properties of this particular set? One way is to count the number of elements inside of the set. This is called the cardinality of the set. Any number used to describe how many is called a cardinal number. But cardinal numbers aren't the only way we can use numbers. Sometimes order is important. For example, panda is the first element in the set, and dog is the third element in the set. Any number used to describe order is called an ordinal number. Finally, we might use a number to label, without regard to cardinality or ordinality. For instance, let's pretend all these animals were on a basketball team, and they had numbered jerseys. These numbers are used for reference, and are not used for counting or for ordering. These numbers are called nominal numbers. This slide contains a quick summary of the three ways we can use whole numbers. A cardinal number answers the question, how many? An ordinal number answers the question, in which place? And a nominal number is a label that we use for referring to objects. The set of whole numbers is usually defined as the set 0, 1, 2, 3, and so on. Some people choose not to include 0, so it could also be written as the set 1, 2, 3, and so on, depending on what book you use. The set of whole numbers may also be called the set of natural numbers, in which case we might use a fancy n to represent this set. 3, 2, 1. In some ways, the idea of cardinality, or how many, exists in our brains as we begin to develop. However, our concept of cardinality is pretty limited. For example, we might only be able to distinguish between one object, two objects, and many objects. Because of this, elementary schools spend a lot of time fostering the concept of cardinality by subitizing. Subitizing is the action of knowing how many objects are present without having to count them all. Think about rolling a pair of dice. We already know how many pips are on each side after the dice are finished rolling without really having to think about it. Students should practice not only subitizing, but also connecting the model to the decimal digit as well as the written word. Elementary students need to be able to do this before they're able to apply their knowledge about mathematics to more formal concepts like adding and subtracting. Another important aspect to foster in the early grades is the idea of order. For example, in these two dominoes, which side is larger? Here we can see that 3 is less than 5 and 6 is greater than 5. I can see this on the first domino because I can actually see 3 comparatively. So I know that 5 has 2 more than 3 does. Over on the other domino, mentally I can move this pip up here and see that 5 is 1 less than 6. It's interesting because the concept of cardinality, or how many, tends to be more important in the early years. However, the concept of ordinality, or being able to order like we just did, gradually becomes a better predictor of mathematical proficiency as students grow older. Next, let's discuss place value. We work in what is called a decimal system. This means that we use the 10 digits 0 through 9, and that every decimal number can be written in expanded powers of 10. You may remember using a place value chart like this one when you were younger. In each place, or each light blue box, we are permitted to use only the digits 0 through 9. I couldn't, for example, put a 14 here in the tens box. Well, I could, but 10 tens is actually 100. More on this a little bit later. For now, what I want you to know is our place value chart helps us think about what we call expanded form. We can write expanded form like this. I have 2 hundreds, 4 tens for 40, 7 ones, 2/10, and 1/100th. It's also possible to write this string of addition using powers of 10. 2 times 10 squared plus 4 times 10 plus 7 times 10 to the 0, because 10 to the 0 is equal to 1. 0.2, or 2/10, is 2 times 10 to the negative 1, or 2/10. And 1/100th, 0.01, is 1 times 10 to the negative 2. Base 10 and place value are not really natural concepts for elementary students, despite how natural they feel to you and me right now. Later in our course, I will challenge you to learn another base system so you can really understand how foreign this feels for our students. To help model decimal numbers, we use manipulatives called base 10 blocks. On the left, we have the ones block, which typically represents a single unit. Next is the tens block, which typically represents 10 units, and you can actually count all 10 of those units inside of this 10 block. Next is our hundreds square. This typically models 100 units. A little bit later, we may also see how this can be used to help model tenths and hundredths, or some of our decimal numbers. Finally, we have our thousands block, or our thousands cube. And as you may have guessed, there are 1,000 units inside of this cube. On this slide is a quick summary of the decimal number system. We call it the decimal system because it's a base 10 system. We use the digits 0 through 9 to represent all of our numbers, and any number can be expanded using powers of 10. All right, let's get to modeling some numbers. Let's say we have some base 10 blocks, and they're shown here below. What whole number does this collection of base 10 blocks represent? Well, we could go through and count. So I see 5 units here and 3 more, so I see 8 units altogether, or 8 singles. I have 6 and 3, which is 9 tens. And I have 2 and 2 for 4 hundreds. So putting it all together, we have 4 hundreds, 9 tens, and 8 units. Our whole number is 498. One connection we might like to make is our base 10 blocks to our place value chart. So here we might want to start with our ones first. I see 6 plus 3, that's 9. And 9 is an acceptable digit that I can use in the base 10 system, so that's perfect. Next up, I see 4 tens, and I can put the number 4 inside of the tens column. That's totally acceptable in the system that we're using. And then finally, we have 2 hundreds blocks, so I can put a 2 here. 2 is an acceptable digit, so altogether we have 249. For our last example, we have a place value chart given to us. And we're going to write this in both expanded forms. And after we're done that, we're going to model using base 10 blocks. Our first expanded form is going to look like this. We have 1,000 plus 300 plus 5 tens is 50 plus 2 units. I could also write this using powers of 10. 1,000 is 10 cubed, or 10 to the power of 3. 100 is 10 squared, or 10 to the power of 2. I can write 50 as 5 times 10 to the power of 1. And 2 is 2 times 10 to the power of 0. Finally, if I wanted to model this using base 10 blocks, I could start with my thousands. I need 1 thousands cube. We have 3 hundreds, so I need 3 of those big 100 squares. I have 5 tens. Okay, so we'd have 5 of our 10 blocks, which look like long rods. And then we have 2 units. For units, if I'm modeling in base 10 blocks, I'm going to use dots. These would be our small cubes. All right, my little epsilons, stay positive.